Patrick, just, yeah.
Yeah, cool.
Stand by, yeah, behind the box.
Okay, audio's live. Good.
Okay, welcome to DevOps Playground. Again, for another month, this time in London. Next month we'll be probably in Manchester, so we begin a travelling circuit. So for those who haven't been here before or joined online and never seen it before, we do it monthly. It's a meetup where we try to share something cool, something a lot of our engineers learned or know, or generally want to share. We believe in learning by doing, so the idea is that we provide you some environment you can break and mess around, so you don't need to worry about your laptop exploding or anything alike. And you don't need to worry about installing all the stuff because it should be pre-installed. We are in the Global Logic office, which is our sponsor, so we all work for Global Logic. Usually we're recruiting as well, but don't feel obliged. So yeah, today we will be writing plugins for Vault in Go. It's kind of a follow-up session for what we did in October. You can find it on YouTube if you want to come back, but it should be also followable on its own, so don't need to have the previous knowledge. The idea is that you should be able to come here and follow with basic skills without going too deep and then explore further. Yeah, the next month we'll have Nginx. I think we'll announce it soon, but here is your preview. And I'll stop talking because I talk too much, and I'll leave it to James and Wale, who are gonna do the show today. So enjoy it.
Thanks, Patrick.
Way too much talking.
So, hi everyone, I'm Wale. So, today's playground is on building Hashicorp Vault plugins with myself and James. So I'm going to walk you through the PowerPoint first, and James is going to be the one in charge of the lab sessions. So yeah, right. So first of all, we need to cover what Hashicorp Vault is. Vault helps to protect workloads and sensitive data across any environment by enabling users to secure, store, and tightly control access tokens, passwords, certificates, and encryption keys. And you can do all of that using their Hashicorp UI or CLI, or also their HTTP APIs. So as you can see, here's an example of a use case for where you would use Vault. On the left, you would see there's lots of systems like applications, and you also have loads of users. And then where Vault comes in as a solution would be where each team would have only access to their own secrets by having just like namespaces or Vault mounts that just belong to each team. So that's where Vault actually solves the problem. So it's not a case where you would never be sharing passwords via emails or other unsecure ways, basically. So now, Hashicorp Vault plugins, which is why we're here today. You can write plugins for Vault, and Vault supports 3 types of plugins, which is the auth methods, secret engines, and database plugins. This concept allows both built-in and external plugins to be treated like building blocks. So basically, we have the built-in plugins here. Actually, sorry. Oh, another thing to mention is any plugin can exist at multiple different mount paths. Different versions of a plugin may be at each location, which with each version different from Vault's version. Now, the first thing is built-in plugins. So those are plugins that already come in with Vault. So you wouldn't have to do anything. You could access them straight away. And they are often commonly used integrations and can be used without any prerequisite steps. And as you can see in the image, you can see examples of those plugins. Now, we also have the external plugins. So Vault's external plugins are commonly separate standalone applications that Vault executes and communicates with over remote procedure call, which is also RPC. So this means the plugin process does not share the same memory space as Vault, and therefore can only access the interfaces and arguments given to it. This means a crash in a plugin cannot crash the entire Vault. So Vault also communicates with external plugins over RPC to secure the communication. Vault creates a mutually authenticated TLS connection with the plugin RPC server. So plugin makes use of the auto MTLS feature of Go plugin, which will automatically negotiate mutual TLS for transport authentication. And then also there's a link to the libraries, which you can go through later on in your own time. Also, now to the last slide, which is the plugin development. Developing a plugin is simple. The only knowledge necessary to write a plugin is the basic command line skills and also basic knowledge of the Go programming language. James is going to walk you through this section a lot more in detail through the lab. So your plugin implementation needs to satisfy the interface for the plugin type you want to build. So you can find these definitions in the docs for the backend running the plugin. And now I'm just going to pass it to James for lab.
Okay. Does anyone have any questions about that? I feel a whistle stop tour about Vault and how what plugins are, but any questions? Everyone happy? In which case, let's get on to the lab. So if we go to the lab.devopsplayground.org, which I was hoping I could just click from that. Yep, see all the secrets. Right, lab.playground. Yeah, so if we go to lab.devopsplayground.org and type in our meetup username, I don't know if I registered for this one. What's my name? I did. So if you type in so this is your meetup display name. This generally is the hardest part of the playground. So if you can't get an environment, please talk to one of the staff, one of the people that are here, either Patrick or some of the other guys, or if you're online, put a message in the YouTube or in Slack, they can reach out and get that sorted. For this one, we're going to use both the IDE and the terminal. So if we just open both of these, and we log in with the Vault 23 password, we should get to this screen here. And then I'm just going to trust the author of this. And the last thing we need is the README, which is in the DevOps Playground GitHub repo. And it's this Hashicorp Vault plugin with Go. And I'm just going to pause here for a moment and give people time to log in or ask for help if they are struggling. Also, if you didn't sign up for the meetup, there is accounts that we can give. But yeah.
Would you just mind unplugging and replugging the thing? We're getting a little bit of like ADS thing through the cable.
Good old technical issues to start. I'll fix it.
Yeah, that's good. Thank you.
Sweet. And hopefully that's been enough time. Is anyone struggling on YouTube or anything? We all good?
What did you say the password was?
So if you look on the thing, it's under the password. So it's Vault with a capital V and then 23. And that should let you in. I'm also going to just rearrange things to make it a little bit easier to see what's going on. And then I'll zoom in. Okay. Hopefully that is readable and we can see what's happening. So the first thing we need to do is in the WETI terminal, we just need to go within workdir, and then the Hashicorp plugin with Go directory, which is kind of the repo that we've pulled down onto all these boxes. And then we've got some files. We're just going to run the start file to begin with. So just sh ./start.sh. So what this is doing, and I will actually open the code editor and just go into the project and load it up. So all this is doing is this is using no-hup, and it's spinning in a background process. Oh, Grace? You're good? Yeah, you need to sh.start. So no-hup, so this is running Vault as a background process. I don't know why I was having issues with Docker doing it. I tried to do this with Docker to begin with. I think I was just impatient. So I'm just running the Vault as a backend process, and then I am waiting 5 seconds for the Vault cluster to spin up. And then I'm setting inputs for environment variables, and then we're just unsealing the Vault cluster. This is a really bad way of doing it because it means that we're kind of losing all the information. But for a very quick way of spinning up a cluster that works with plugins, it works just fine. And when this is done, you'll see at the bottom line, that is our root token. So what we want to do is you just want to export that into the environment variable. So once you run the start, the last line should be the token. So you just want to, I suppose I can do that. The last line is the token, and you just want to set that into your Vault token. If, for whatever reason, Wetty crashes or the Vault token gets lost, you can just use your bash history to find where you've set it before. Obviously, that's a security vulnerability. This is a quick and dirty playground, so it's fine for now. And then we're just going to set the Vault address to use HTTP because it uses HTTPS by default. So this should let us access Vault. So if I clear and then go Vault status, it should show all the information.
Question for you: would a Dev Vault work for you?
The Dev Vault does different things with plugins, so it doesn't care about the SHA of the plugin. So within this, the Dev Vault would have been fine. I just wanted to use something fancier.
Just for my knowledge.
Yeah, so the code we do later, we get the hash key of the file we build, and then we use that when we load the plugin into Vault. Whereas in the Dev Vault, it doesn't care about the SHA. You can just be like, load this plugin, because it's designed for obviously quick and quick and dirty experimentation. I think the main reason why I did it this way is setting the config file. Saying the config location, the documentation was all about actual Vault, so I just did an actual Vault cluster. I didn't look crazy detailed into why I was doing it this way. I just picked away and ran with it.
Oh, it works?
Yeah, if it works, why not? Okay. Hopefully everyone has unsealed their Vault cluster and got the root tokens in. So we can now actually look at some of the code. So within our editor, I'm just going to, so we've got all our code files on the left. We've got kind of the base skeleton. I think Vault would see this as a plugin if we ran it. It doesn't do anything currently. So I've just copied from the example that they give online. This is kind of a base main file that the Terraform will see and will run the plugin. And then this calls it's plugin serve, and then it calls our backend that we set, which in the backend.go file, which is the first file we're going to mess with. Actually, so this one returns an error because I thought about that. But if you just return nil-nil, it would probably be happy. So the way we're going to change this is this factory function. Do I need to zoom this in a little bit? So this, we're just going to replace the factory block with these 3 lines. And then we're just going to do one more thing, which is loading all this data. And for whatever reason, it likes using tabs, which really makes everything harder to format. Okay. I'm just going to put this data up here. So what this does is this sets a struct, which is a framework backend, and then we are just we're just creating a new backend. This is just running the function to kind of build it as a factory, and then we're running the setup script that comes with the framework backend. So we're just doing some very basic setup for this plugin. And then we are going to go back into our terminal, and we're going to do go mod tidy. And what this is going to do is this is going to download all the imports that we have set up at the top of the file. This takes a moment while it's just downloading all the Go files, so we'll just let this sit for a bit.
While it downloads, can I ask you something?
Yeah?
How does the plugin interact with the backend? Does it use the same backend as Vault? Like if you're using, I don't know, say, console?
So I suppose I realised that we have a microphone here I should be throwing you. So the question was, how does the Vault plugin interact with the backend?
Yeah, does it send an RPC call to Vault to store data?
Yeah, so the way, I haven't massively gone into the low-level tech, but the way I believe is Vault does an RPC call to the plugin, which has some functions we're going to define in a bit, which is how the information goes through. And within that, there is a storage object, and that is the object that we are directly interacting with. And my assumption with that is there is, because we're passing pointers through to the object, so we're editing the data there, which I don't know if you need two-way RPC or if there's something behind the scenes that I don't know about in the modules we're including that does that return of the kind of stored data. But the plugin itself has no idea how Vault's set up, what the storage type is, if it's console backend, if it's a Raft backend. All it knows is I have this storage blob that I can read and write information to. This Go is actually one, takes forever. Oh, it's done, that's good. I really should have. We kept thinking about like auto doing this before we started, and we never got around to doing it. But it's fine, it gives people time to catch up and make sure I've not made a horrendous mistake. Okay, so that is now done. So the next step is we actually need to edit a little bit more code. So now we're going to edit this backend function that we've created. So we're going to load in all this information. So this is what actually tells Vault what this plugin can do. So we have a nice little help function that we'll fill out in a bit. We've got some paths which let you do things in a way that's really like secure and clever. So you can have local storage, which is if you're doing high availability or kind of disaster recovery, more like the big enterprise things within Vault. You can tell it that the password shouldn't be replicated between clusters. So it'll only be ever on that cluster. And then you've got seal wrap storage, which is if you're using something like an HSM, so a hardware storage module, you can tell it what paths to encrypt a second time. So both Vault will encrypt it and the HSM will encrypt it. Those are only things that really matter in large-scale systems or enterprise, or if you're building a very secure, well-made plugin, that's when you start having to go down those things. For this silly little example we're doing with today, I'm going to stay away from them. The paths will mess with them a bit. This is where we tell Vault the actual paths that we've used. So when you do the plugin path / something, this is what tells it what the slash is. Secrets, I kept meaning to look up, and I keep forgetting what that actually means. We don't use it. I haven't seen a reason to use it. No, I believe it's the paths that it won't output the information to, so kind of won't read. Like, it says secrets, the things you should worry more about. Backend type, this is what the example had, and I have seen no reason to change it. So now we've done that. There's a few more imports we need to do. When I was deving this locally, I had a Go plugin for Visual Studio Code, which auto-populates all the imports. Because we're using the online one that doesn't have that, there's just a couple places where it's like, oh, we need to change the imports. Because if the imports aren't used, Go complains. If the imports aren't there, we need them, Go complains. So it's kind of, we have to add the imports as we go and occasionally just run Go more tidy again, which we will do, but this one is a lot faster than the last time we ran it. As the fact it ran instantly. So the next step is we have done the bare minimum of what a plugin needs to do. Let's load into Vault. Let's actually see what this plugin looks like. So I have saved you having to write 5 commands every time we want to run this. So I've made a makefile. It could have been a shell script. I don't really know why I did a makefile over shell script, but it's a makefile. So this is the SHA stuff I was talking about earlier. So it gets the 256 SHA of the file when we run it. So it's a very simple Go command. It then runs make install. It then runs this block where we deregister and disable the plugin. If the plugin doesn't exist, those lines don't do anything. So it's just kind of, we can clean up after ourselves before we add it again in the future. We then load in the SHA. Because of the way make works, when we add in this variable is when the command to get the SHAs run. So we can kind of just run it at that point. And then so that registers the secret, and then we're enabling the secret. So this will make it a path available for us to use. So now I'm going to go back into Wetty and go make build. And hopefully, this will take a bit, and then it'll work. Should have run this before I started talking about it. This one, though, does not take that long. Which does? Yeah, so so as if you want to connect to an HSM, so Vault in itself has a system to connect to HSMs through key shares. So you can say, use HSM to store your keys. And then within the plugin system, you can tell it which paths should be double wrapped through the HSM as well. So if you have one path that's got secrets, obviously that you'd want to be double wrapped. But if you've got one that's just storing like usernames or I don't know, like metadata about the stuff, you don't really need to encrypt that twice. It's just going to slow down the getting that metadata out. Do you have a question? So that's, I mean, it's a good question. It's saying, why is it saying no such file direction? So the way the makefile gets run is it runs that SHA line first, at least in the Linux version. And because this file hasn't been built yet, the file doesn't exist. So it kind of runs that line first, fails, but then it runs it again when it gets to this point. So it's fine. It's a weird error that I don't really know what happens, but my make knowledge isn't maybe what it should be.
Make is essentially a compilation command.
Yeah.
Okay, I mean, basically it eats up on the
Yeah, so it could be a shell script. Yeah, I've just used make quite a lot recently, so my brain was in make over bash at that point. So we should, I'm just going to clear the screen to make it cleaner. We should have our secret engine enabled.
Sorry, I've got a lot of error deregistering plugins.
So the first thing it'll do is deregister, but because there isn't a plugin, it may not be happy. It should be fine though. What does the error say?
Error deregistering plugin named DPG Vault plugin.
Yeah. So we haven't enabled the plugin yet, so it should be fine. I don't actually remember if mine did that. I would, if the rest of the commands work, it's one of those kind of, we're trying to do something that doesn't exist at that point. So, but if I go Vault secrets list, that's nice, spell secrets. So we can see here, this one here. So this is the plugin we've created. And you can see all the other plugins that kind of come with Vault. So everyone gets a cubbyhole, everyone has an identity store, which is how the tokens get managed, and sys, which is all the system stuff that anytime you look at documentation is like, be careful when you mess with sys because you can just break Vault. So within the Vault system, there is kind of a path help where you can go like, this is the path, what can we do with it? So we'll run that against our newly enabled plugin or newly enabled secrets engine, and we can do nothing with it. We haven't added anything, we haven't done any paths yet. So let's add a help. Let's add something that's going to be in the description to tell us what we can do with this plugin. So if I go back into the backend file, and then we just add this command to the bottom, we're going to separate our strings just to be better programmers. I'm sure there's a reason to do it, but kind of making it so it's not just embedded in this massive block of text. So if we just replace this help here, so this is going to trim any spaces we've got at the start and the end of the message, and then it's just going to turn that into help. Because we haven't imported strings yet, there's just the import block we need to change again. And then that should be it. So now if we rerun make build, fingers crossed when we run this again, I don't know why it's quicker the second time. Go seems to be significantly faster the second time we run it. But yeah, now if I go get this help thing again, and we have a description. It now tells us what our path does. Obviously, if this was a proper system, you'd have a far more useful description that will tell people how to use it. But there's still no paths. It's just a blank plugin that can't do anything. So let's add some paths. So to do this, we are going to make a new file. Just to spare my spelling, I'm going to just use the touch command because yeah, I would spell it wrong otherwise, and that will make us a new file. So we now have our player path file. Within Go, files don't really mean anything if they're in the same directory, as long as they're in the same package, sorry. So as long as we make sure the package is the same at the top, this could all be in one file. Splitting just makes it easier to debug and work out what's going on when you need to edit anything. So let's add our player path code. So this is, if I just make it so we can see more. So this is the code that says what the paths we're going to mess with are. They take in a regex pattern to tell you kind of, or they can take in a regex pattern to tell you what the path we should accept is. So this has, within the framework library, there is some kind of generic regex things that we can care about. So this is going to be a generic name regex. So this is going to be the name of, in this case, the player. It's kind of like a D&D character sheet, which we're building in a secrets engine, which maybe isn't the best way of a secrets engine, but it was a good use case when I was messing with it. So this is going to be our character's name. And then if you've seen regex, this means everything, the exclamation mark $. So this is going to be, just run this on anything we give. Something to think about with paths, and we'll hit it a little bit later, is the order matters. So because it hits the first one, if anything matches the first regex, it then won't hit the second one. So so when we have a config directory later, if that wasn't above the player's name, you would just get a player called config. You would never be able to set the config. Yeah, so now we've done that, let's just add our imports, which normally is at the top here. And then we're going to open our backend file. So we go back to our backend file and this block we made earlier. And where there is no paths here, we are just going to replace that line to add in some paths. So we are passing through the kind of backend, so we're kind of passing through ourselves, just so we can get some information from that, which is the information we are loading in here. And then everything just kind of gets loaded in. Yes. I suppose your question of how Vault knows about the storage, all of this ends up being returned as a backend to Vault, so Vault will then know how to kind of parse it and mess with it. Yeah, so now we've got a backend, but it's empty. Like we can make a player, but they have no data. They need, obviously, experience and classes and all that. I could have made a lot more, but it's maybe an issue I have with Vault and Terraform is the majority of these plugin things is working out what the hell this schema should look like, which is good because it makes it simple and easy, but there's a lot of just schema writing when you start diving into these things. So within the player paths in this field, make sure it's the top one, not the second one. We are just going to replace it with all this field data. And it's going to, so we've got the name, which is linked to kind of this class name. So it's the same, it'll be the same information. We've got a class, and then we've got kind of an amount of experience. And then while we have fields by default, Vault doesn't know what to do with them. So what we're going to do within the operations tab, in the operations line, is we're just going to tell it what functions to run when we do some operations. So this is when we do a read operation, it's going to run, or it's going to do a callback, which is going to run our player paths read function, which we will write in a little bit. Okay, so before we get into writing the functions, we're going to just make a struct which turns this is going to help us turn the code that Vault gives us into objects that Go can mess with. So Vault stores all of its information as JSON objects. So we're just going to use Go's inbuilt JSON parsing just to make sure that it converts quite nice and neatly. And as I say here, which I think is always, it's kind of the way I code, is trying to separate things as much as possible. So we're going to split up this path player read into a couple of functions that kind of call each other. So if we ever need to get information about the player in the future for something else, we can just call the same bits of code. So to start with that, we're going to do a get player block. So this code, it is, what's interesting about this code? So we've got the logical store, which is where Vault stores all its information, at least at a Go coding level. Everything gets stored in this logical store. And then we've got the name, which is the name we defined earlier up here. So that's the kind of identifier of the player and kind of where in that logical store we're going to store under. So what we do is we obviously make sure name's been passed. If name's not passed, we just error out, return a helpful error message. If you wanted to make Vault more secure, and something I didn't think about until I started doing a dry run for this, is actually error messages aren't always the most helpful thing within secrets. If someone has stumbled across your path and you're returning an error message saying, oh, you've not returned a name, oh, you've not given me this information, it may be easier for them to work out how to get the information they want out of your system. So you may actually just want to return nothing and just be like, there's no error messages, we're going to be not helpful because that can be a security concern. I like error messages while I'm debugging. You may also want a debug build that has the error messages and a production build that doesn't, just so people can kind of learn how to use it, but then maybe more secure in production. We're then going to use the get command from the storage. We're passing in the context. I believe this lets us do timeout. This lets Vault do timeout stuff. But generally, we just pass the context around, and Vault deals with what that actually means. And then we pass in the name. So we're just saying, from the store, give us what's in this name. We're then making sure that it's not errored. We're then seeing if it returns nothing. So if the entity is nothing that it's got from that name, it's just going to return. If there's, I don't know where there's a time when there'll be no data stored under the name, but there could be. And it's just like, if that happens, just return. We're then creating a entry of the struct we made just a moment ago, and then we're just going to run the decode JSON into that struct. So we're just decoding the information that Vault's given us into a entry object, which we're then going to return, and that means we can then do more interesting stuff with it.
What's the signature of the callback? Where are you getting the entry?
So this is a function we've made. It's not really linked to Vault. So this block here, it's probably the lines are too long, is saying what the return is. So I'm just returning the structure we've made and then an error if anything's happened, which is quite a common Go kind of return, is the information we want and then an error. Yeah, that question was about the callback. Yeah. I was just, I can hear you, but it's online is the problem. It's remembering that we're streamed. All right, so the next thing we're going to do is so this is what Vault actually calls. So this is the player paths read. So this is very much defined by Vault. So this takes context, a request of what's being sent. The field data is this information. So it's what Vault sees this information as when it's being passed through, which it's a read command, so it's probably not going to be anything, and we probably only really care about the name of that. And then Vault requires a logical response and an error. So this is very much defined by Vault. So we are running the get player we did just a moment ago. We're passing the context. Out of the logical request, we're getting the storage object from it. And then we're doing a get of the field data to get the name, and we're just converting it to a string. The error processing of this we've got within the function itself. So if this returns null or empty, the function we're calling will just deal with that. We're then doing kind of the same error checking we did before. If error is nil, if there's an error, return the error. If entity is nothing, just return back up. Because if there is no data there, we don't really want to return anything. And then this is the information that Go needs us to, the function needs us to return. So returning a logical response, which is a key value object, and I suppose it's a struct, sorry, which is a struct, which has data, and then we're going to make a response data struct function in just a moment to return a map of string interfaces, which I just stole because the code is right here, so I just copied that. So this is the code that this bit calls. All we're doing is from the player entry data that this is extending, so we have access to all the parts of the struct. We're just going to make a map which is just kind of name and the value we want. And then we just need to add a couple more imports at the top because we are using context and format to do some string manipulation. And while I would love to be able to build and show you this now, we have no way of loading information into Vault. So we need to implement the write command before we can then actually use the read.
Up to this point, do you still need the other fields like class and experience, or are you just operating with one field and that's the name?
So we've got a way of reading it. So you only need the name. The class and experience is purely just to show loading some data in and being able to read it. You could get rid of them if all you wanted was the name. And even then, if you wanted to have it something else, there's probably a way of removing that, which when we get to the config later.
So the other fields there, the class and experience, are used for the write operation?
So this is the data we're storing. So this is I suppose the question is what the class and experience used for. This is just we're using this as kind of a key value store. So we're just giving our object a class, which I suppose class isn't the best word, but like a fantasy class, so like Paladin or Healer or something like that. And the experience is just a number. So if we got rid of this, it would work just as well. But this is kind of the data we're reading out of the system. And then the write command is how we populate that data to then be able to read it with the read command. Hopefully that makes sense.
So you don't need to declare your output type. That's the input. These are the fields that
Yeah.
you call.
Yeah, these are the input.
And the output is whatever you get.
Yeah, so the output is this map is the output. If I wanted that to be hard-coded and not actually care about the rest of it, I could. And actually later on in the example, we're going to calculate some information based on the values we've already loaded and then output that. So you can't go in and set it. It's just data that's computed by Vault. So for that way, if you wanted to have a server somewhere else that you got a username and password from, you would just have the read command, and it would then reach out to the server, get a username, password, and then just print that out, and you wouldn't even need a write command at that point. Yes. So next step, let's write some information. So we're going to edit this operations block, which could only read. And we are going to edit it with this block that's here. And because of the way that this code is written, we get the create operation and the update operation within the same code. So we're just going to write code that's good enough that if it's a create, it'll do one thing. If it's an update, it'll do another. There is maybe times when you'd need a different create and update, but for this use case, there's very little reason to. Okay, and then we'll add, in the same as before, we're going to split the code that does kind of the base logic and the thing that Vault calls apart. So we've got this set player function. Wow, everything's just indenting weirdly. Oops, that's not bad. Yeah. Oh, that's made it worse. Oh well. So the set player, the same as before, it takes in a context, a storage, and a name. And then this also takes in the player entity. So this is going to be the information that we want to load into Vault. And then it just returns an error if something goes wrong. So the first step is we're just going to use the logical storage entity JSON command, which just does, I think, most of the work for us. And so we give it a name, and we give it the player entity, which is all the information it has, and it loads it into a variable. We then error check, see if it's null. Obviously, if it's null, something's gone wrong, so we throw an error. And then we just run the put command, which loads in the entry we've made into the Vault backend. And that's kind of as simple as loading data into Vault is. Obviously, if we wanted to manipulate data or do different things, we can do. Within the next code, which is what calls this set player, we do some error checking and code manipulation. So this is the code we've set for the operations to call, and it is almost identical to the read. Actually, it is identical to the read. We've got the requests, the field data, and we're turning a logical response and an error. So we're doing a little bit more on the name this time. We are seeing if the name, if we are passing a name through. If not, we are throwing a response. We are returning an error message. We're not actually outputting a response. We're not returning an error message. Sorry. We're not returning an error. We're returning a response that is an error, but so we'll just output differently. We're then going to run our getPlayer function that we wrote earlier. And this is just going to see if the player already exists. So if it already exists, we don't just want to overwrite all the information. We may just want to edit it and update it. So this is why that code returns a lot of, if it's nothing, just return nil. So then if it is nil, we're going to create one. So we're just going to create an empty object and set it to the same variable we've been using up above, which is this player entry one. We're then seeing if this is a create operation, which lets us do some things within the bottom two, when we're actually seeing if the values exist or not. We're then seeing if we can get the values from field data, and if we can, we just set it. We set the value into the object, which we can then store when we call the set player at the bottom. And then we don't really need any output, so we're just returning nil. If we wanted to return the information we just passed in, we could call the to response data the same as we do at the end of the read. And now we can make sure this all works. So if I clear the screen and we want make build again, that was nice and quick. So now if I go Vault, I'm going to diverge a little bit from what I've written on the slides, and I'm going to run path help again. dpg Vault plugin. So if we see here, these are the two paths that we've created. So this is the kind of generic name regex, which I'm sure someone that knew regex could tell me what that means. But it's just kind of what Vault accepts as a name. And then this is the everything regex. To save my typing, let's load in some data. I am a Final Fantasy player, so I'm going to put Red Mage as my class, because that's what I enjoy playing. And then, so we just need to make sure that we do the Vault write, and then it's the plugin name, and then slash the name of the player, or in this case the player. Obviously this is the object we're setting. So I'm setting the pandas class to Red Mage. And then when I do the Vault read command, luckily it's all worked. And as we can see, we have the class set, and the experience is set to 0, which is the default. If I wrote a class and I set the experience to something, though I can never spell that. So if I say, put myself as the class, and then go experience equals 10, and then I just read, so it says the class is NA. So this is where you may want to, within the set player, within the kind of create functions, go if something's not been set, you may want to set a more useful default, because NA can break things depending on how your systems are built in the future, or how the system's built. And in the same way as we set my experience to 10, if we set the panda's experience to 10, and then read the panda, you can see both the sets. So while we set both the fields separately, they've been added together just because the way the code has been set. So if we had more lines, we can individually add them, or we can do one long command to set them all at the same time. Next, we're going to deal with this, the second pattern, which is the list. So while I've got 2 players, I have no way currently within the plugin to see what players I've created, so kind of what secrets I've stored. So there is the list operation within Vault, which we are going to set up now for this pattern. So make sure you're under the $$ pattern, and we are going to change the operations line to this one, and fix my formatting a little bit. So the same as before, but this is the list operation. So if we wanted the list operation for the other one, we can just add a line that's list operation and manipulate it that way. And luckily, this command is nice and short, so you shouldn't have to hear me waffling about how Go works anymore, at least for this one. So this is the same function signature as before, and all we're doing is listing all the information that's in the kind of the root of the storage area, the root of the path. Oh, have I broken? Oh no, just broken 2. Okay, my markup is not as good as it should be. So if I go back here, and I'm going to quickly run make build, and then this bash line, and I'm just going to add another one. So I'm going to add James as well. So we've built it, we've added 2 with this new kind of list path stuff we've got. And then if I run Vault list, you can then see a list of all the secrets. So yeah, so we can see within that, there are all the secrets. If we obviously want more information there, we could output we could extend this to be far more information than just here's a list of entries. So now we've done we've got create, we've got update, we've got list. Just suppose it isn't part of the CRUD, but it's close enough. Let's delete. Let's tell Vault we don't want the secret anymore. How we actually delete it. So if we go into the fields again, so this is the top one, back where it's under the generic name regex, and we want to replace the fields with this one, which is exactly the same as before. It is just the delete operation this time, and we are going to run some delete code, which the same as list. It is very simple. Well, I say simple. It's very short. All we're telling Vault to do is delete the data. There's not really any error checking. If the data's not there, maybe it'll throw an error, but whether it gets deleted or not, the user can see that, oh, maybe the name didn't exist or whatever. It's all just kind of more on the user to see what's going on. While I hope you trust me when I say that works,
I was under the impression that Go had a conditional, you can make a conditional statement with Go, and when there's an error, it doesn't delete it. It hasn't deleted it.
Yeah, so if there is an error, it'll just return the error message. So then it's up to the user to go, why didn't it delete? And then if they haven't given the name or they've not given some information or something else has gone wrong, the Vault code, the plugin shouldn't have been the reason why it didn't delete. Because as long as the name is given and the data exists, there's no reason why the kind of Vault plugin code shouldn't work. Obviously, if you wanted to do more error checking because it's a production system, then yeah, definitely. but yeah, hopefully this is a pretty bulletproof delete, because I would hope Hashicorp know what they're doing. It's my hope. So yeah, I've given 4 commands that just show delete working, which, yeah, so as you see, we do a read. Wow, this is hard to see. That was a bad idea. So we write some data. We then read it just to prove the data exists. We then run the delete, and we get our nice, if it exists, it's deleted line. And then we run it again. It says there's no data found. And step 4, which I think is the last step, because there's a lot of code. But yeah, step 3, this is where we are. So the next thing we're going to do is I'm going to show you the config part of Vault. So this is a way you can give kind of an admin access to a path that your users can't, but then the code can still access the information that your admins have loaded in. So I'm going to do one more thing in this file, or a couple more things in this file, hopefully. We're going to do a get level function. So all this is going to do is this is going to take in the amount of experience the player's got, and it's just going to return a level. It's doing a very basic, just square root it, and that's a level. We're then going to edit our toResponse data. And this is where maybe I should have wrote my code a little bit better. toResponse, this one. So we're just going to add the level at the bottom, and this is just going to be computed. There's no way for kind of the user to interact with this, the value this gets out, other than give more experience. The last thing with this is give in some maths, because we are now square rooting, so we just need to do the maths. Oh, that's a spelling mistake. Maybe don't copy that one. And then I will just go make build again. Oh, that was maybe not needed of a step. That was step 3, and that was what? 2 things to copy? That's fun. And now if I give the player some experience and read its level, so I'm giving it 1,000 experience, which is 31 square root to 31. We now have a level, so that is how simple it is to do just computed information, which is, yeah, nice and quick, nice and easy. So the final step is the config, which I thought these two were together. So this is the information that the admins, well, the people that get access to one path can edit, and people that get access to others maybe can't. And you've all seen most of this, so this is going to be a little bit of a quicker step than the last one. So we're just going to touch the path, touch the file again. So this will make the file, which I could make within Visual Studio just as easily, but touch commands. And then I'm just going to copy and paste this information. This is exactly the same as when we were starting the path setup. We've got the package, got some imports. We've got the config. The only fields we're doing here is a starting level. No name, nothing like that. Just one simple field. If you obviously had other fields within your code, you could add them, but nice and simple. And then if we go back into the backend code, so this is the file we started right at the start, and within the paths, we're just going to replace it and add the paths config at the top. This is what I was saying about earlier, that if we had them the other way around, you could never actually edit the config because you just create a player with the name config instead. This does have the weird side effect as well. That means you can't have a player named config, which maybe would matter in real life, but weird bugs in systems. Yeah, so back to the configs. We're going to just set all the operators at the same time. We've seen all these. You've got read. It's doing the same write, double write for create and update, and the same delete. Delete like we've done earlier. And the code is very similar, so we're just going to add some like basic config useful stuff at the top. So this gives us a path which we're going to store our config at. So this would be where in the logical store we're storing the config. Then we're creating our struct that has the kind of the Go data and the JSON. And then this is the get config that other parts of the system can call as well as this to get the config so we can get all the information. So we're doing the same get commands to get it from the store. And then we're creating a new one. There was a reason why I needed it. It was weirdly erroring, and I think that I needed to do this to fix that. But this is where you kind of create the config that we then decode and return. And then as this code is copied from player path and tweaked to use new data, there is all the CRUD operations. So we've got the read code, which is just reading the information, and we're not even doing a different function this time to export the information. We're just returning the level because it's only one thing. And then the write, it's the same as before. We are seeing if it's the create and if it's config is nil. So we're making sure if the config exists. Oh, if we've not set the variable at the top, then that will error. Wow, I've not looked at this code in a long time. But yeah, this is very similar to what we were doing for path, because in Vault there's no difference between the config and the path. It's just how we're deciding to use it. The last thing that this file needs is an existence check, which is just a way of Vault seeing, does this path already exist? Because we need this path to exist for our code now to work. So it's just going, if it doesn't exist, do something. Or it errors if it doesn't exist. And then we just add this line into this block at the top. I'm just going to put it underneath the operations. And then the last thing we need to do is make use of the information that we've just set. So within the player path, we're just going to edit the get level and let this take through. Oh, I need to replace all of that. So we're going to edit the get level. So all this is going to do is it's going to take an int for the starting level and then just add it to the maths we were already doing. We're then going to, when I was editing this, I was running it and seeing what failed, which is why my comical responses. We're now going to edit the to response data again, which I'm just going to search for again, because last time that was painful to find. So we're just going to do the to response. And this now takes in the player config that we set in the config file, and then we're just going to get the starting levels from that config when we do the read. And then the last thing we need to do is in the player path, so this block here, we are going to run the code that it's going to run the get config function we specified in the other file. We're going to do some error checking. If the config is none, we're just going to create one, because otherwise it will just error. So this would, in this example, this create a config that would have a starting level of 0, sorry. If your code required the config to exist, at this point you may want to just error and be like, no, I need a config. I'm not going to let you progress without it setting. And then we're just going to pass that through to the response data. And then next step is we build it. And then hopefully that's all built. I have given myself a couple commands to make my life easier. So what is it doing? These are running Vault write. We're setting the config path, and we're just setting the information. We're then making another class like we've been doing the rest of the night. And then when we run read, we should see the level is 10, even though we've had no experience. We've got no XP. And that is hopefully a tour of Vault plugins. Does anyone have any questions? Any questions online? No, everyone's happy? Our pizzas have arrived, which is maybe why I sped up a little bit at the end. But if there's no questions, then thank you everyone online for watching. Thank you everyone here for watching, and we'll see you next month. Well, next month in Manchester, so maybe online we'll see you.